Hello everyone. In this video, we will find the derivative of square root of 10x using the first principles. So you have to know that if we are given a function y equals to f of x, then by first principle, our derivative will be y prime equals to limit h tends to 0 f of x plus h minus f of x over h, where this h is the small increment in x. So compare this with our given function. We will get f of x equals to square root of 10x and f of x plus h will be the square root of 10x plus h. So our derivative will be y dash equals to limit h tends to 0 10x plus h under root minus the square root of 10x over h equals to limit h tends to 0 1 over h. Now to get rid of this square root, we can multiply the numerator and denominator with its conjugate. So we can write 10x plus h under root minus the square root of 10x multiplied with its conjugate, square root of 10x plus h plus the square root of 10x over the square root of 10x plus h plus the square root of 10x equals to limit h tends to 0 1 over h. So if you see, this is similar to a minus b and a plus b, which is the formula for a square minus b square. So you can just write 10x plus h minus 10x, and in denominator we have square root of 10x plus h plus the square root of 10x equals to limit h tends to 0 1 over h. So now what we can do is change this 10x plus h and 10x into cos and sine. So 10x plus h will be sine x plus h over cos x plus h minus, and 10x will be sine x over cos x times square root of 10x plus h plus the square root of 10x equals to limit h tends to 0 1 over h. Now multiply the numerator and denominator with cos x, sine x plus h times cos x over cos x plus h times cos x minus, now multiply the numerator and denominator with cos x plus h, sine x times cos x plus h over cos x times cos x plus h times 1 over the square root of 10x plus h plus the square root of 10x equals to limit h tends to 0 1 over h. Since we have common denominators, we can write it as sine x plus h cos x minus cos x plus h sin x over the single denominator, a common denominator, cos x plus h times cos x times 1 over the square root of tan x plus h plus the square root of tan x equals to limit h tends to 0, 1 over h. So if you see here, it is similar to sin A cos B minus cos A sin B, which is the formula for sin A minus B. So we can write sin A, which is x plus h, and minus B, which is x, over cos x plus h times cos x times 1 over tan x plus h under root minus the square root of tan x. So let me go to the next slide. Control C, Control V. So this is our y prime equals to limit h tends to 0. This x and this x will cancel, and we are left with sin h over h. So multiply limit h tends to 0. Now 1 over cos x plus h is similar to sec x plus h, and 1 over cos x is sec x, and in denominator we have tan x plus h square root minus the square root of tan x. Now this is 1 times, now use the limit, put 0 in place of h, we will get sec x times sec x over the square root of tan x plus, I think here must be plus, yeah, it is plus here, plus the square root of tan x equals to the sec x times sec x will be sec square x, and square root of tan x plus square root of tan x will be 2 times the square root of tan x. So this is our derivative for square root of tan x. Thank you.